Let's go ahead and graph another rational function. We need to graph lots of these to get really good at it. So I have f of x is x squared plus 1 over x minus 3. Let's set the denominator equal to 0 to find the domain and vertical asymptote. So I get x equals 3. That means my domain is all values of x such that x doesn't equal 3. And my vertical asymptote is x equals 3. So here's our vertical asymptote. Yeah. Oh my gosh, why did I sing that? Now it's recorded forever. Okay, so here's x is 3. Next, we want to find our other asymptotes. And that depends on the degree of my numerator, which is 2, and my denominator, which is 1. So the degree of my numerator is greater by exactly 1 than the degree of my denominator. So I'm going to have an oblique asymptote, and I find that by dividing my numerator by the denominator. So what do I multiply x by to make it look like x squared? That's an x. X times x is x squared minus 3x. I made a tiny mistake here. Remember, when I'm dividing, I need to have a placeholder so that each degree is represented. Go ahead and subtract. I get 3x plus 1. What do I multiply x by to make it look like 3x? Well, that's a 3. 3 times x is 3x. 3 times negative 3 is negative 9. We subtract these. I'm left with a remainder of 10, but we ignore the remainder. So my oblique asymptote is when y equals x plus 3. So that means my y-intercept is 3, and my slope is a positive 1. I'm trying to sketch this as nice as I can with a dotted line. Alright, there we go. I tried my best. So this is the line y equals x plus 3. In order to graph these functions, I need to find a few points on either side of my vertical asymptote. So let's go ahead and make ourselves some room for that. All right, what points should I pick for x? Oh, I guess we're changing color. So let's do when x is 0, 1, 2, and then 4, 5, 6, because I can't use my asymptote. And maybe we won't do all of these because that's quite a bit of math. And I have been talking for quite a while. So I have, when x is 0, that gives me 0 squared plus 1 over 0 minus 3. That gives me a negative 1/3. So when x is 0, y is negative 1/3. X is 0, y is negative 1/3. We'll go right there. Now for 1, I have when x is 1, that gives me 1 squared plus 1 over 1 minus 3. That's 2 over negative 2, which is a negative 1. So I have when x is 1, y is a full negative 1. Cool. Next I have when x is 2, that gives me 4 plus 1 over 2 minus 3, which is 5, divided by negative 1, which is a negative 5. So when x is 2, y is negative 5. So my graph is going to look something like this. It's going to approach my asymptotes but not touch them. Now let's take a look at when x is 4. We're going to make ourselves some more room. So when x is 4, that gives me 4 squared plus 1 over 4 minus 3, which is 17 over 1, which is 17. So when x is 4, y is 17. Oh my gosh, it's like off the charts. When x is 5, that gives me 25 plus 1 over 2. So 26 divided by 2, which is 13. So when x is 5, y is 13. And when x is 6, I think this is going to be off the charts too. I've got 37 over 3. 37 divided by 3, that's like 10, 12, 12 and a half-ish. It's going to be right like here. This is what my graph looks like in black. And as always, you can check that in Desmos. Last but certainly not least, here's a new one. I've got f of x is 1 over x squared minus 9. So let's go ahead and set our denominator equal to 0 to find our domain. I have x squared is 9. Take the square root, x equals plus or minus 3. So now I have two vertical asymptotes. So my domain is all values of x such that x doesn't equal 3 and x doesn't equal negative 3. So my vertical asymptotes are x is 3 and x is negative 3. Friendly reminder, when you take a square root, you have to take both the positive and negative. Also, this is the product of a sum and a difference. If I had factored this, which is probably what I should have done, I would factor to x plus 3, x minus 3 equals 0. Okay, and then I could have found my vertical asymptote. So let's go ahead, sketch these in. Here's x is negative 3. And here's x is positive 3. Now, my degree of my numerator is 1, and the degree of my denominator is 2. If the degree of my numerator is less than the degree of my denominator, I have a horizontal asymptote at y equals 0, which is the case here. So here's my y equals 0 horizontal asymptote. Now, in order to graph this, I need to find a few points in each section of my domain, right? So I need to find some points here and here and here, some y values. So let's set that up. This is going to be quite a bit of math, so be prepared. So let's look at when x is, let's just do 2 points in each. Let's do x is negative 5, negative 4, negative 1, 0, 1. That's important to do those three. And then 4 and 5. And you're going to notice we probably are going to have some symmetry here. That's what I think. So I have 1 over negative 5 squared, which is 25 minus 9, which is 1/16. So when x is negative 5, y is a positive 1/16. So let's try and draw that. When x is negative 4, I have 1 over a positive 16 minus 9, which is going to be 1 over 7. Why did that take me so long? So I have 1/7, which is a little bit higher. So we can tell it's going to look like this on our left-hand side. Now let's take a look at a middle. So y is negative 1. I have y over 1 minus 9, which is negative 1/8. When x is 0, I have y over 0 minus 9, which is a negative 1/9. And the same thing when y is 1, I have 1 over 1 minus 9, which is negative 1/8. Notice the symmetry here. So when x is 0, we've got negative 1/9, negative 1/8. Trying my best here. It's going to look like this. Now you're going to see we'll have some symmetry on this right-hand side because I have 1 over 16 minus 9, which is 1/7, and 1 over 25 minus 9, which is 1/16. So we're going to have symmetry, which is beautiful. So here is our rational function. So if you need some extra help, check out this guided notebook activity on graphing functions in Desmos. Let's take a look real quick. Okay, so you can start out by, matching rational function, part with its found. So to find the y-intercepts, you set x equals 0. And to find the horizontal, to find the vertical asymptotes, you set the denominator equal to 0, right? Like you can match these things up. So it's got some fun little activities for you guys if you feel like you want some extra practice. And it lets you know if you're right or wrong right away. So it's a good interactive.